Okay, so 9.3, we're going to be graphing quadratic notes. So the goal, so by the end of this lesson, you all should be able to graph a quadratic function. Okay? We're not going to get through all that today. That's a good question. There's a lot of example problems on there. We're not going to get through it all today. So when we graph quadratic functions, there are 5 steps, which might seem overwhelming, but you know how to do all of the steps except for one of them. You know how to do step 1. You know how to find the equation of the axis of symmetry. We did that yesterday, and we did that in our opener. Remember axis of symmetry? What's my formula?
X
equals
B.
B divided by 2A. Good. So you guys know how to do step 1. Step 2, you know how to find the vertex. You know how to tell if it's maximum or minimum. You already know how to do that. We learned that yesterday. Step 3, you know how to find the y-intercept. We learned that yesterday, and we reviewed it again today. Step 4, this is the new point. Using the vertex, we're going to use symmetry to find additional points on the graph. That's the only new step. Step 5, how many of you guys have ever did the connect the dots?
Yeah.
Okay, that's all you're going to do. Connect the points with the smooth curve. Why do I want to make sure my curve is smooth? What am I trying to create for a quadratic function? What's that? A what? Parabola, which then will fold over and be symmetrical. Okay, so you're only really truly learning one new point today. All right, let's put them into play now. So what I've given you, example number 1, you have a quadratic function here. So you have the function of x, or f of x, equals x squared plus 4x plus 3. We're going to go ahead and just look at the equation, and you're going to tell me if it's maximum or minimum based on the equation. It's going to be what? Minimum, because the a value is what? Positive. So minimum. So if it's a minimum, is the graph going to be up, open up, or is it going to open down?
Open up.
Up. Good. So it's going to open up. So yeah, so now we're ready to find the axis of symmetry. You guys told me that the axis of symmetry, the equation is going to be x equals negative b divided by 2a. Okay? So I go back to my quadratic function, and I look to see what I substitute for b. So what do I substitute for b?
4 would be for b, and then 2, it would be 1.
Good. So I'm going to substitute 4 for b, and then for my a, I'm going to substitute 1. And then from here, I just simplify, which simplify is pretty much solve. So negative times 4 is?
Negative 4.
And then?
2 times 1 equals 2. And then negative 4 divided by 2 equals negative 2.
So my axis of symmetry is x equals negative 2. Okay, so if I found axis of symmetry, x equals negative 2, I found 50% of my vertex. I've already found half of my vertex. So what do I know about my vertex?
The x is negative 2.
Yeah, so a vertex is an ordered pair, and the x value for my vertex is negative 2. So now I just need to identify what the y value equals. How do I identify what the y value equals?
Y equals, you want to substitute negative 2 for the x.
So we're going to use our original function, or our original equation, and we're going to substitute for the value of x. What am I substituting for the value of x? Negative 2.
And then it'll be plus 4 times, and the parentheses will be negative 2 again, and then plus 3. And
okay.
Negative 2 times 2.
Okay, let's give everybody a second to get that down. Any questions on what we have covered so far, which is basically a review of yesterday? So according to our notes, so right now we found step 1, so we're working on step 2, okay? So when I go to simplify this, I use order of operation. What's negative 2 squared? Positive 4, so negative 2 times negative 2 is positive 4, okay? And then keep using PEMDAS to simplify. So positive 4 times negative 2. Good. Yeah, negative 8, and then I bring down my plus 3. Okay? When I go to simplify further, remember, Multiplication and division is a step together. Addition and subtraction is the same step. You do whichever one comes first, left to right. So you have 4 minus 8, which equals
-4.
plus 3, -1. So the function of x is basically my output. My output is my y value. So my y value equals what? -1. So my vertex is -2, -1. Yes? If it is an emergency and you can't wait, because I'd like to try to get through 2 to 3 examples. Okay, so the y-intercept. Now, we're not talking about the y-axis. I'm talking about the y-intercept, where that parabola is going to go through my y-axis. What is my y-intercept? 3. So how do I write that? 0, comma 3. I write it as an ordered pair. So remember, my y-intercept comes from my c value in standard form. The one other point, that's going to be our symmetry. That's going to be the new part, and we're going to come back to that in just a second. We're going to go ahead and answer domain. What's the domain of this quadratic function? All real numbers. And then, what's the range going to be?
Fx
So f of x
is greater than or equal to -1.
-1. Where did that -1 come from?
The y.
The y-axis, right? Not the y-intercept, the y-axis in my ordered pair. Okay. Or excuse me, the y value in my ordered pair. Now, we're ready to graph. So all this stuff that we did was all review. When we go to graph, the very first thing I'm going to graph is the vertex, okay? The vertex is going to be an ordered pair, and the vertex is also going to be my minimum value, or the minimum, or the maximum of my parabola, right? And it's going to be right in the middle. So the vertex is going to be -2, -1. So I'm going to start at my origin, which is right in the center of my graph, and I first graph my x. So which direction do I go? Left 2, and then y? Down 1. So there's my vertex. After I graph my vertex, I'm going to graph my y-intercept. So my y-intercept is 0, 3. So I start at my origin. My x value is 0, so I stay put. My y value is 3, so how many do I go up?
3.
1, 2, 3. Now, using your vertex, you're going to use symmetry to get an additional point. So symmetrical. So we want to be able to fold it over at my vertex. So basically, I want to be able to fold it over from this line and have a point on the exact part of that other purple line, my axis of symmetry. So if this is my vertex, how do I get a point directly symmetrical to it?
You go left 4, -4,
Okay.
and then up 3.
Good. So what's that ordered pair that you just came up with, Dylan?
-4, 3.
-4, 3. So that's your other point. Okay. Now you're ready to graph it. So you know because it's a minimum, it's going to be up. And you're going to try to make a nice smooth line through all of your points.
That's a nice smooth line.
I did the best that I could. Just show that your parabola is facing up. It's a minimum. The minimum value is, what's my minimum value? You guys have already told it to me. What's my minimum value? What's the low point? What's the low point? But your minimum value would not be the vertex. Your minimum value is just what goes up or down, which is the y part, which is -1. -1.
Wait, I don't know what would be -2.
The y value, the -1. Okay. Let's take a look at example number 2.
Wait, we didn't do the order. The one other point.
We did. Dylan, what was the one other point?
Oh, never mind.
-4, 3.
-4, comma 3.
I didn't.
Can't wait. Yes, you have to take my big wooden pass.
Yeah.
Okay, example number 2. So example number 2 is very similar to example number 1. Okay, so let's look. Looking at this quadratic function, is it going to be a maximum or is it going to have a minimum?
Maximum.
Why? You're right. Explain.
-2. The negative A.
Good. Because this is a negative, we know that it's going to be maximum. Meaning, is the graph going to be up or down?
It's going to be down.
Okay. Can you guys think of an example of a parabola that you see in everyday life that would resemble a maximum?
Half-Life.
I don't know what that is.
Skateboard.
Oh, okay. What else would? I'm loving it.
That's me. No, that would be a minimum. No,
Not if it opens down.
No.
The McDonald's arch,
Yeah.
if it opens down.
The arch.
The arch. Yeah. Okay. So once we've determined that it's maximum, it opens down, we're ready to find n. As long as it's not like a cursive n, it's just like a lowercase. We're going to find the axis of symmetry. Who in here cannot tell me what the axis of symmetry is? The formula. Is there anybody that does not know the formula yet? Look it up on your notes right now and tell me what it is.
Is it x equals negative b 2a?
Yeah.
Okay.
So what do I substitute for b?
1, 2,
Okay, and what do I substitute for a?
2.
Oh, so close.
Negative 2.
-2, yeah. Okay, now simplify it.
It would be -4.
I disagree.
No, the bottom one, sorry.
I start at the top.
Oh, so -2. And then
-2.
-4.
Over -4.
E-
There you
I really want you to wait till the end of notes if possible. So 2 negatives equal a?
Positive.
If I take 2 divided by 4, what am I going to get?
OB2.
Positive 2.
In your calculators, take 2 divided by 4.
It would be a decimal.
It's going to be a decimal.
So you do -4 divided by -2.
You can't do that. You can't flip it. It's got to stay in the order that it's in. So what you're going to do, you're going to leave it as a fraction, but we're going to leave it as a fraction in simplest form. So what's 2/4 written as a fraction in simplest form?
1/2.
1/2, good. So my x value is going to actually be, so the axis of symmetry is going to be x equals 1/2.
Wait, can you just take away
So
the
where would you graph that on your x-axis? Where would half fall between? What two numbers?
1 and 1/2 would be right in between 1 and 2. 0 and 1.
0, 1, much better. Okay, so we know part of our vertex, we know the x value is going to be half. Now let's find our y value. Robert, how do I find what my y value is going to be? Toby, can you help him? How do we find out what my y value is going to equal?
Substitute x into the equation.
Yeah, so what am I going to substitute for x, Toby?
1/2.
So -2 times 1/2 squared plus 2 times 1/2 minus 1. Good. Now, working with fractions we haven't done for quite a while now. Remember, you have a calculator that you can use that does fractions. So what's 1/2 squared? So what's 1/2 squared?
2/4.
1/2.
It's going to be 1/4.
Oh,
Good.
I thought it would have been 1.
Okay? I'm just going to rewrite this here. Now, we're going to take -2 times 1/4. What's -2 times 1/4?
-2 and 1/4.
Mm-mm.
Right.
So -2,
2.
2 times 1/4.
Neg- -2 times 1/4 is not -2.
-1/2.
-1/2. Then what's 2 times half?
2 1.
1. And then I bring down my -1. All right? So we're going to solve. Think about it. If I have a half and I add 1 and then I take that 1 away, what am I going to have?
1/2.
Half. Good. -1/2, right? -1/2. So what's my y value?
It would be 1/2, comma, -1/2.
Good. So it's -1/2.
And then
Okay.
the y-intercept would be 0, negative.
-1.
Good.
Yeah, -1.
Okay, the other point we'll come back to, domain,
All your numbers.
okay, and range.
Um,
The function of x, or f of x.
X.
Now its maximum,
It would be less than or equal to negative 1/2.
because we use, because in our vertex, in our ordered pair, we use the y value in our ordered pair. Okay, so from here, what do I graph first? What do I graph first?
The origin, the vertex.
The
sorry.
vertex, okay?
Vertex origin.
So I graph my vertex first, then I graph my y-intercept. So I start my origin. Now my vertex is half, negative half. So I go over half and I go down half, which would be about right there on my coordinate plane. Okay? What's my y-intercept, which I graph next? So next I graph my y-intercept.
That would be negative 1. 0, negative 1.
Okay. Now my symmetry, my one other point is going to be my step 4, finding the symmetry. Which point do I use to find my symmetry? Do I use my vertex or do I use my y-intercept?
No, your vertex.
My vertex, because the vertex is that axis of symmetry. So if I'm using this as my axis of symmetry, I need to draw a point that'll be symmetrical to that. So where would I draw my other point or plot my other point?
The other side.
What do you mean by the other side?
Something that's symmetrical to your last one.
Yeah, so what's that ordered pair going to be if I make it symmetrical, Lucas?
Where's it at? On 1?
So it would be 1,
-1.
good. So there's where that other point comes from. And then we go to plot or draw our line as smooth as we can possibly make it. This is not going to be very pretty on my part.
Got it.
And there we go. Questions? Okay.